What we're working on in this video is graphing inequalities. It says inequalities with two variables, meaning that there's an unknown x and an unknown y, and so that we're going to graph this on the coordinate plane. This is just the same as graphing an equation, so the first thing I would think about is writing this as an equation and just thinking about graphing that first, okay? So I'm just going to write over here y equals 6 plus 1/3 x. And I'm going to graph those points, a couple of those points, and then we're going to talk about how we turn that equation into an inequality on a graph. Now, first thing we're going to look at here is, here's our graph. It doesn't have any scale on it. The coordinate grid doesn't have a scale. So I'm just going to assume that it's going to go up by ones because I think I'm going to have enough room with that, and that would be fine. If you're not going to have enough room, you're going to have to change your settings and maybe go up by 2s or go up by 5s or 10s, but this equation should fit on here with ones. So first thing to start with is the 6. That 6 is the y-intercept. And so that's the coordinate pair 0, 6. Okay, and it's the y-intercept 0, 6. I'm going to go find that point. So I'm going to go over 0 on the x, and I'm going to go up 6 on the y because this is x, y. So over 0 and up 1, 2, 3, 4, 5, 6, and make a dot there. And then it says my rate of change is 1/3 x. So change in y over change in x is 1/3. And so that's a vertical change of 1 and a horizontal change of 3. And so that's saying I'm going to go up 1 and over 3 from that point. So I'm going to go up 1 and then go over 1, 2, 3 and make a dot. And that's my new point. I went up 1 and then I went over 1, 2, 3 and made my step. Up 1 over 1, 2, 3 and made my step. Up 1 over 1, 2, 3, and I'm going to continue to do that. I'm going to work my way back because my graph line actually does go back here. I'm going to continue that pattern backwards. If I went up 1 over 3, then I need to go down 1 and back 3. Down 1 and back 3, so that when I draw this, it would be a straight line. Okay, I'm not going to connect my dots just yet because now I have my equation and there's my points that will make that equation. And remember, it was an equation, but we really want to graph the inequality. Okay, so the only difference here is what this line is saying. It's saying our y value is going to be less than all of these answers. So here's a general rule of thumb. If it is a less than or a greater than, then your line that you're going to make is dashed. Okay, it's dashed. Because that means anything on the line actually is not a true statement. Let me highlight this yellow here. Okay. And if it is a less than or equal to, like it has an equal to sign part, or greater than or equal to, then the line is solid like it would be with an equation. And the reason being is because those points on that line would be a true statement. Okay, so first off, because this is a less than sign, it's going to be dashed. So as I go ahead and make this, I'm just going to dash these points. And my graph line's looking something like that. Because, again, does not have an equal to sign, so it's dashed. The next part of the inequality is, where's the true statement? So I'm going to think about through these points here, and I'm just going to pick some points. Like example, I'm going to pick the point 0 or 1, 3, that point right there, and see if that's a true statement in here. And so when I do that, that point there is 1, 3. I'm going to check to see if that point is a true statement with that inequality. Well, in this, my y would be 3 is less than 6 plus 1/3 times, not x, I'm sorry, times 1, right? Because it would be 1 there. So there's that coordinate pair showing that for x and y. 6 plus 1/3 times 1 is still 1/3, so 6 1/3, so this would be saying 3 is less than 6 1/3. That is a true statement. Yes, 3 is less than 6 1/3. If I were to pick a point on the other side, like for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, let's pick up here 10, 0, 10. I'm going to check to see if that works in this equation. So my y here is 10. It's less than 6 plus 1/3 times 0, because there's my 0. Right? 0 was replaced with my x, and y was replaced with my 10. 10 was replaced with my y, sorry. As I do this, 6 plus 1/3 0 is 6. Is this a true statement? 10 is less than 6. This is not a true statement. So that means the stuff on this side of the line is not true, and the stuff on this side of the line is true. And so we have a part that we're going to shade. So anything on this side of the line is a true statement, meaning that is our shaded region. Okay. Anything down here would be a valid statement for that equation. Does that make sense as I'm looking through here? Anything up here would not. And as you think through what this sign says, y is less than, if this is our y, then the shaded part needs to be on the less than side of the dotted line here. Okay, because the less than y, like this is 3, that's less than the line here. This is 8, that's greater than the line here. Okay. What else can I add to this? Okay, so if it is a y is less than, or a y is less than or equal to, the shading is going to be below the line. Okay, shading is below the line. Y is going to be greater than, or y is greater than or equal to, the shading is going to be above the line. All right, let's look at the next one. It's a little more complicated as we work through this. It's complicated because we've got to rearrange it, right? So we've been working on rearranging equations. It's going to be the same thing when we rearrange this inequality. We need to be thinking about when we divide what happens here. I'm going to draw a line down the inequality sign. I'm going to subtract 6x. I'm going to subtract 6x over here. Cancels that out. I'm left with negative 2y is less than or equal to 10 minus 6x. And then I'm going to divide by negative 2. Divide by negative 2. Now, anytime I divide or multiply by a negative, my inequality sign flips. Inequality. Divide or multiply by a negative, my inequality sign flips. So what's going to happen right now is I'm going to divide this by a negative 2. So now it's just y, and because I divided it by a negative, not a positive, since I divided it by a negative, this inequality sign is flipping to the other direction. I'm going to do 10 divided by negative 2, and I'm going to get negative 5. And I'm going to do negative 6 divided by negative 2, and I'm going to get a positive 3x. Here's our new inequality. Okay, so this is what we're graphing. Here's our y-intercept. Here's our rate of change. Our y-intercept is 0, negative 5. And our rate of change is change of y over change of x is 3 over 1. Okay, so I'm going to go 0, negative 5. 1, 2, 3, 4, 5. There's that point. And it says I'm going to go up 3 and over 1. So I'm going to go up 1, 2, 3 and over 1, make a dot. Up 1, 2, 3 over 1, make a dot. Continue that. And I'm going to work it backwards in that same pattern. Okay, so it is the inequality sign that we've got. It has an equal to, so anytime it is greater than or equal to or less than or equal to, it's a solid line, not dashed, because those points on that line are valid. Okay, Next thing I'm going to look at is, how is my sign? Well, it says my y is greater than. And this says when the y is greater than, the shading is going to be on the top. So on the top of this is this side, okay? And so as I shade this, all of this is my true answers. And I'm going to now check them so that you can make sense of how that just happened. I'm going to check the point 1, 1, because that's a nice easy one. I'm going to check that point right there with my equation. My new equation is y is greater than or equal to -5 plus 3x. And we're going to check that point right there. And so that's 1, 1. So 1 goes in for y. It becomes -5 plus 3 times 1. -5 plus 3 times 1 is -2. 1 is greater than or equal to -2. Yes, that's a true statement, so therefore it needs to be shaded. I'm going to try another one on the other side, like I'm going to go over 2 and down 2, and I'm going to call that -2, +2, -2. Went over +2 and down -2. And so I've got my equation y is greater than or equal to -5 plus 3x. And so when I put those points in, there's my y, so it's -2 is greater than or equal to -5 plus 3 times 2, because I put in the 2 there. 3 times 2 is 6, plus a -5 is 1, so our answer is -2 is greater than or equal to 1. Not a true statement. That is not a true statement, because it was -2 is not greater than 1, and so therefore this side does not get shaded. So our things that we've learned on here is when it's solid versus a dashed line. Okay, when it's a solid line versus a dashed line. It's solid when it has an equal to sign on it. It's dashed when it is just greater than or less than signs here. We also learned the shading. When it's shaded above the line, then it's going to be a greater than. It's going to be a y is greater than, or a y is greater than or equal to. The shading is going to be above the line. We learned that when the shading is below the line, it's y is less than, or y is less than or equal to. The shading goes below. We also learned that you can take a coordinate pair if you can't remember those rules, and you check your answers. And you can see that when you have a true statement, the shading goes on the true statements. When you have a false statement, the shading does not go in the false statement, because the shading is indicating where the true answers are. We also talked about this, and this should be a review from several years ago. Division, or when we divide or multiply by a negative number, the inequality sign flips. Okay, so remembering that if we divide or multiply by a negative number, the inequality sign flips as you're rearranging for y. Now, if you divide or multiply by a positive number, the sign does not flip, so it's only when it's a negative number. All right?